Hey guys, it's another fun-filled day in math class, and we are moving on to Chapter 5, Section 6, the Fundamental Theorem of Algebra. Let's see what they want to tell us here. Every quadratic polynomial, which is quadratic means x squared, has two roots. Every cubic is going to have three roots. Every fourth root will have four, so on and so on and so on. This result is related to the fundamental theorem of algebra. The German mathematician, that guy, is credited with proving this theorem. So what that means is if you have x squared, guys, that means you're going to have two roots. So two roots. Okay? If you have x to the third, you're going to have three roots. And if you have x to the fourth, I think you're getting it, you're going to have four roots. And this will go on all the way till x to the millionth root, and you'll have a million roots. Okay, something just happened in my video and it cut me off, but don't worry, I'm back. Let's take a look at problem 1 and see how well we can do with the stuff we learned from yesterday and then from chapter 4. So we have this x to the 5th power, and they want us to find all the roots. Notice yesterday it would have said find the rational roots, but today so we are going to use the concept from yesterday. Step 1, please make sure it's equal to 0. And just like I said yesterday, if you're not listening, you have no idea. I just look like I really like the number 0. But we have to make sure it's set equal to 0 and that this stuff is in order. So check and check and check. Now what we need is to find all the factors of this back number. So all factors of 4, like 4, 2, and 1, and divide each of those plus and minus by all the factors of the 1 in the front. Oh, we love it when there's a 1 in the front because the only factor of. Now I'm going to grab my calculator, and I am not going to plug these in by hand because I will use my tool that I have, my calculator. But if you don't have that tool, you are going to have to go ahead and plug them in by hand. So I will type my equation x to the 5th minus x to the 4th minus 3x to the 3rd plus 3x squared minus 4x, I feel very official with my headset on, plus 4. I hope someone comes in my door and looks how cool I look. All right, and now after your equation in, you hit second graph and you type in the numbers you want to try. And look, just from my numbers I had typed in before, I can already see that 2 gives me a 0 and that 1 gives me a 0. So I'm going to kind of like circle those. So 2 and 1 already were in my calculator, and they are already rational roots, and they come from 2 over 1, and what was the other one? 1 over 1. Now I am going to try all the other ones as well. So I'll try 4, I'll try negative 4, I will try negative 2. Oh, look, negative 2 works as well. Circle that one. So far I have 3 answers that are rational, which is very nice. Tried negative 2, let's try 1, which we already know, and negative 1. And that is all of them. So we did positive negative 4, positive negative 2, positive negative 1. And I have 3 of them already. Now remember, because this was x to the 5th, there are going to be 5 roots. I have found 3 of them that are rational already. So let's label that as 3 rational, which means there's going to be 2 that are either not rational, like meaning they can't make a fraction, or 2 that are imaginary. So how do we solve for the other 2? So I'm going to write solve for the other 2 roots, because we already have 3 of them up here, and I need 5 total. So in order to do that, I got a lot of synthetic division coming my way. All right, so synthetic division, what did we learn that in? Section 5.4, I think. I'm going to take all the coefficients up here. So 1, negative 1, negative 3, 3, negative 4, and 4. I'm going to line them up. Please notice nothing is missing, so I don't need to substitute any zeros in. So let's start with 1, negative 1, negative 3, 3, negative 4, and 4. Again, this was x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then the x was technically x to the 0, but no x. So put your box on there and pick any of these rational roots. I don't care. Sure, let's pick negative 2 and do synthetic division with negative 2. So I'm going to drop down. I'm not going to use my calculator. I got this. So you drop down the 1. I love synthetic division. You can do long division if you feel like, being miserable. Negative 2 times 1 is negative 2. Negative 1 and negative 2 makes negative 3. Multiply negative 2, negative 3, positive 6. Add negative 3 and 6 and get 3. If you're struggling with this, please go back to the 5.4 notes. Negative 2 and 3 makes negative 6. Add 3 and negative 6 makes negative 3. Multiply negative 2 and negative 3 makes positive 6. Add negative 4 and 6 makes 2. Multiply negative 2 and negative 2 makes, negative 2 and 2 makes negative 4. You get a remainder of 0. Now, if you did not get a remainder of 0, something went wrong. Either the root you found was not rational, or you did your synthetic division wrong. This has to be a 0 remainder if you proceeded on the problem correctly. I don't know. I don't teach English. All right. Now you got to do synthetic division again, but you're going to do it with your new number. So I guess I should probably write smaller. 1, negative 3, 3, negative 3, 2. I'm not actually going to even make an equation out of it. That would be a waste of my time. Just do synthetic division again with one of the other numbers we didn't use. So we already used negative 2. So this time, why don't we do positive 2? And I'll draw an arrow because why not draw a million arrows to confuse somebody who's not understanding? Sorry about that. So put positive 2 right in here. I pointed at the computer screen, like you could see me pointing at the computer screen. All right, drop down this 1. So here it is. Multiply. 2 times 1 is 2. Add. Negative 3 and 2 is negative 1. Multiply. Negative 2. Add. Positive 1. Multiply. Positive 2. Add. Negative 1. Multiply. Negative 2. Add 0. Hey, I'm so happy I get a 0 there, because if I didn't get a 0, something was really wrong, either with my rational root or with my synthetic division. Okay? Now, I know this is like super duper exciting for you. We can do synthetic division again, which is incredible. So I'm going to take my new numbers, 1, negative 1, 1, and negative 1. Oh, look at that cute little pattern. That's just by chance, by the way. And now I have to do synthetic division with my one I haven't done. So the rational root I haven't used yet, boop, 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 is that positive 1. So I'm going to put positive 1, boom, right there. Oh, this is exciting. All right, synthetic division, drop that down. So I get 1, multiply 1, add 0, multiply 0, add 1, multiply 1, add 0. There's your remainder. Yippee skippy, we got 0, so we know we did it right. Now we have to go back and think about section 4 again. So section 4, we've used all our rational roots. There's nothing else that we can do except solve this as a quadratic. So if you remember, this is like x squared, 1x squared, plus 0x, so I'm not writing it, plus 1. Now remember, in order to solve for the roots, we have to set this thing equal to 0. So you know what works with all quadratic problems? Well, of course you do, because you love the quadratic formula. Now, if you want to, you guys can solve that if you remember how to without the quadratic formula. I'm going to do it with the quadratic formula only because it's one way that works all of the time. But yes, there is a shorter way. So I will do negative b. Remember, this is a, b is 0, and this is c. So negative b is negative 0 plus or minus the square root of b squared is 0 minus 4 times a is 1 times c is 1 all over 2 times a is 1. Oh, the quadratic formula. We love it. So that's 0 plus or minus the square root of negative 4 all over 2. Well, that's, oh, look how tiny my handwriting's getting. I bet you really wish I would have wrote smaller over there. That's 0 plus or minus 2i, because of the square root of negative, over 2. The 0 is useless, if you guys remember that. I'm sure you do. So I literally have, I'm just going to erase the 0, if you don't mind, because 0 is useless. Look at that. So we're going to cross off these 2's, and the two other answers, are plus and minus I. So there are the other 2 answers that we're hiding. There they are. So if I want to write all 5 of them and I want to list them out, I sure can do that. Let's write the 5 roots that I got. I got 2, which was normal. I got 1. I got negative 2. I got I, and I got negative I. And if you count all those up, boom, 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 1, 2, 3, 4, 5, we got 5 of them. So there they are. Really sorry about how much room I didn't leave you. My bad. All right, the got it, I guess I do in a different video. It's been a while. Problem 2, let's try to do it again. This is so much fun. I know you're excited. Good news, this is only going to have 4 answers, not 5 answers like the one on the front. So it says, what are the zeros? Guys, that means what are the roots? It's like, where is it crossing the y-axis, okay? I said that wrong. It's where it's crossing the x-axis. Maybe I'll just, like, rewind and get that out of there. It's where it crosses the x-axis. Embarrassed. So set it equal to 0. So we have x to the 4th plus x to the 3rd minus 7x squared minus 9x minus 18. All right, my bell rings in 7 minutes for 3 o'clock, so I can do this in 7 minutes. It is set equal to 0. It is in order, so let's do the rational root thing, right? So guys, we're going to get out of here in 7 minutes, at least on this problem. You still have the rest of the videos to watch. Sorry. So you have x to the 4th plus x cubed. It's weird that I enjoy this stuff, isn't it? Minus 7x squared minus 9x minus 18. I can sing you in rendition of Baby Shark if you want to. Baby Shark doo-doo. So now I just got that in your head. You're welcome. So we will hit second and graph, and let's play around with some numbers until we get 0. In order to get 0, oh boy, 18. Yikes. Maybe this will take us 7 minutes. We do all the factors of 18. So 18. So 18 and 1. 9 and 2. 6 and 3. And I think I got them all. And thank goodness the first number is just a 1. So what I will do is I'm going to plug in, pretty much since it's over 1, plus and minus of all those numbers, right? 18, no. Negative 18, no. 1, no. Negative 1, no. 9, no. Negative 9, no. 2, no. Let's scroll back up so I'm more. Negative 2, no. 6, uh-oh. Negative 6, I'm getting a little anxious. 3, there it is. So 3 finally gave me 0. What about negative 3? Yay! Oh, magic. So I have 2 answers that are rational, and only 2. 2 rational. It's nice that I gave myself so much room down here, isn't it? But 2 rational is okay, because remember, in this one, I'm going to need 4 total, because I had an x to the 4th. Okay? Don't you love when my left hand gets in the way? So the other 2 are either irrational or imaginary. Let's figure out what's what. Pick one of those. Eeny, meeny, miny, mo. Catch a tiger by his toe. If you yell, siren, go. Eeny, meeny, miny, mo. Negative 3. You should hear my 4-year-old say eeny, meeny, miny, mo. It's pretty cute because she does not say it right. Negative 3 goes in the little box. All your coefficients go beside it. 1, 1, negative 7, negative 9, negative 18. And drop down the first one. Multiply negative 3 and 1 to get negative 3. Add negative 2. Multiply 6, add negative 1, multiply 3, add negative 6, multiply 18, add 0. Be happy, you wanted a remainder of 0. At least I have a lot more room this time than I did on the front page. Sorry about that. Now, that is definitely not an x squared problem, so I can't do the quadratic yet, because that would actually be x cubed when I rewrote it like I did in section 5.4. So now what I need are to use these numbers again. I love synthetic division. And do the rational root you didn't use. So we did eeny, meeny, miny, mo. This time we have to use the one we did not get on Catch a Tiger by His Toe. It's kind of mean, isn't it? Catch a tiger by his toe. Drop down the 1. Really sorry. I'm probably very distracting right now. 3 times 1 is 3. Add to get 1. 3 times 1, drop my pencil there for no reason whatsoever. 3 times 1 is 3. Add to get 2. 3 times 2 is 6. Add to get 0. There's your remainder. Give it a star because you're happy you get 0. And look, here's our quadratic. That's 1x squared plus 1x plus 2. And now we're going to set that puppy equal to 0 and use the quadratic formula. We're going to even draw a smiley face because we love the quadratic formula so much. You guys should draw that smiley face and then you should be like, look, Miss Langeli, I listened to my notes and I drew the smiley face because you said so. And then I'll give you a high five because we all know I don't give you bonus. Okay, so here's A, B, and C. You can factor this PS, it's x plus 1 and x plus 1. Or you can do the quadratic formula because it works all of the time. Negative B, and you are pros at it. Plus or minus the square root of B squared, which is just 1 squared, which is 1. Minus 4 times A times C all over 2 times A. We are quadratic formula masters. That is going to equal... Did I just lie? I lied to you. That's not x plus 1 and x plus 1. Is anyone sitting there thinking that's x plus 1 and x plus 1 and then thinking I'm crazy? Maybe you think I'm crazy already, but yeah, that's, sorry, not x plus 1 and x plus 1. So I get negative 1 plus or minus the square root of, what is that, Miss Langeli? 1 minus 8, negative 7, ew, gross, all over 2. So there's no perfect square that goes into 7, but my negative can come out. Miss Miles tell a funny joke, but I'm going to steal it. She'll say, take your eyes out, but don't go blind. There you go, Miss Miles. I stole your joke. You're welcome. Plus or minus I square roots of 7, because a negative in a square root becomes an I on the outside. There's no reducing. There are technically 2 more answers here. So I'll write 2 imaginary answers. And altogether, we have 4 total. So we had 3, comma, -3, and those ugly answers.
I should make reference that sometimes a +3 can happen twice, but you might not see it happening. It should come out in the works when you begin to factor it, though.
I hope you enjoyed this rendition of Finding the Zeros from Mrs. Langeli. Is there any more? Ooh, look guys, you're almost done.